go. What do we have here? Learn OS++ by example, Part 2, Scene 1, a quick summary of Part 1. Okay, what we're going to be doing is we're going to be discussing this object, and this object, which is actually one object. And what we're going to do is we're going to start with a quick summary of Part 1, just a quick run through. So, what did we do in Part 1? Well, we went to OS++ after installing openscad, and we downloaded the framework. We did that by going to os++.org, clicked on the download or the link, did save as, and we got this download. With this file, we basically took it to an archiver. This is a standard one that comes with my operating system. Hit extract, extracted the files, closed it, and we got two files, this one and this one. This is a welcome message, which because I'm miserable, I'm going to delete. And this is our framework. I'm going to call this my examples. In this subdirectory, we've got a whole bunch of user files with the framework here. I went through and I didn't delete learn hard, which is a list of examples, and template minimal, which is basically the minimal amount of code that you need to run the actual framework. And then deleted them to make life easier. So in summary, I had my framework, my OS++ framework, all the files are neatly in there, my examples, and my template. Moving back out, for the sake of this summary, I've created a bunch of quick examples in openscad. And basically, I just want to go through some of the code that we ran in Part 1. So the first thing that we did in Part 1 was we talked about the declaration. And basically, this is saying this is going to be an amateur piece of user code. Don't judge me. This statement will load up the framework. This statement will set the resolution for spheres and cones. And this is my actual code. And as you can see, it's very sophisticated. And what it does is it will print a cube using this anchor, 0, 0, 0, and this particular shape where X is 10, Y is 10, Z is 10. And if I hit F5, up comes my cube. Now I spoke about anchor points. Now the anchor point of this particular cuboid is here, 0, 0, 0. I then talked about this corner, which is L, 0, 0, this corner, which is 0, 0, L, and this corner, which is L, L, L. Now, this way of thinking is from the point of view of the cube itself. What I want to talk about now, quickly, is that there's actually another view, and that's the global view or the graph view. 0, 0, 0 is basically saying that this cube is going to be in quadrant 1. Quadrant 1 is where the y and the x are positive. Quadrant 2 in mathematics is where x is negative and y is positive, i.e. here or here. So, to do that, all I need to do is change the anchor point and generate another cube. So our shape now, although we're using the same translate point, 0, 0, 0, we've now got two cubes, one which is at anchor point 0, 0, 0, and one which has got an anchor point of L, 0, 0. L, 0, 0, as I explained, means that X is the last point on the cube. So this is over here, Y is still 0, and Z is still 0. So effectively, if we've got 8 corners, we'll have 8 quadrants. So we'll have this quadrant, and this quadrant. Okay. Here's a little bit more. Exactly the same code. We've got a cube in quadrant 1, a cube in quadrant 2, a cube in quadrant 3, and a cube in quadrant 4. So we're now looking from the graph point of view, not the cube's point of view. And as you can see, I've now got quite an interesting shape, which I could 3D print. Now, if you 3D printed this particular shape, it would 3D print quite nicely, but when you put it into your pocket, it would do you a mischief. So what we might want to do is we might want to, I don't know, make the edges a little bit less pointy. And I discussed that in part 1, and all I did was I added a little bit more information to my cuboid. Now we've got a bit of a problem here, because although our cuboid is now rounded, there's lots of rounded areas that we don't want. So we're going to discuss this later, but you're going to have to take my word for it for the time being. You can actually turn off some of that roundedness. So I'm going to add this. What have I done? So I've said I've got a cube. It's a cube because all the sides are the same. X is 10, Y is 10, Z is 10. I've turned around and said I want it to be rounded, but I want to only add this roundedness to ZL. Now what is ZL? Well, in this particular case, ZL stands for the Z-axis and the top of the Z-axis. So if you're talking about the Z-axis as a face rather than a corner, you can see that this is now nicely rounded. And I can actually go through and do that for each cuboid. Okay. What have we got here? Well, we've got our cuboid. We've got our cuboid, which is in quadrant 1, which means it's between the X and the Y axis in the positive nature. And we've only got the top rounded, ZL. The last point, the last face in the Z-axis is rounded. We've also got the same in quadrant 2, which is L00, exactly the same thing, and so on and so forth. Let's remove it. Now the bottom one, a little bit exciting. This is a cuboid at the base. So 0, 0, 0 is here, i.e. the middle of X, the middle of Y, and the top of Z. And we've basically rendered this cuboid down. It's got rounded corners of 2, but unlike the Z last, the Z first, i.e. the bottom part of the shape has been rounded. Don't worry about it, it's too much, we're going to go through this specifically. So if I union all these together, I'd get this shape. Notice I haven't done a single translate. All I've done is I've sort of wrapped round each quadrant, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and then given it a bottom. There's my shape. What happens if I do want to do a translate? How do I work out translates around this object? That's a really good question. The first thing I would do is I would put these, which are very nasty as far as I'm concerned, into a main area up here and give it a name. I might give it a name of cuboid to say it's a cuboid, and then Q1 as a description. That's basically what I've done here. So here I've got a variable defining global, which is Q1, Q2, Q3, Q4. So the variables have now been set up here, and I can now access and render these variables in the same way. And just for a giggle, I've left the bottom in its full glory, which is quite nasty. But from a reading point of view, this makes a lot of sense. Lib cuboid, I want a cuboid. I want the cuboid to be at 0, 0, 0, which is at 0, 0, 0. and I'm going to do cuboid Q1, which just happens to be up here. And these are all my parameters for that particular cuboid. Parameters, as I said, which we're going to go over in greater detail, is x is 10, y is 10, z is 10. The corners are rounded by 2, and I only want the top to be rounded. Everything else is nice and pointy. And what that means is it tessellates, or it goes together properly without any problems. If I removed this, you can see that I have the cuboid, but there's all these gaps around it. Probably would still 3D print, but it would be a little bit strange. It's not what we want. I want the whole cube, and so on and so forth. I want the whole cube to be one shape. Okay. What have we done here? Make sure we've got the commas in. Okay. So this is one shape. It's quite a complex shape. No translates whatsoever. And we've made it readable by putting our primaries in global out of the way, so it's nice and readable. So rather than having to deal with this, we deal with this. You probably don't even need a rem mark, but anyway, I have given it one. Let's go to the next section. Okay. Taking it a little bit further, I've given each cuboid a name as before, exactly the same parameters. I've also explained, I've actually given the cuboid a Q bottom. Now actually in reality that's Q4, Q5, Q6, Q7, Q8. But because I've got a much bigger cuboid here, I2020, and I'm rendering it from the middle, MMML, basically it just comes into the bottom. If I go back quickly, you can see that bottom disappears. Bottom back on. So that's all we're doing, all nice and simple. Now the next block of code, which I've pumped in, is showing you a translate. So to make this interesting, I've actually given it a little bit of color. I've said this color, this block of code is going to have the color green. All right, fair enough. Our translate is going to be calculated for us. And what we're saying is the function is going to be here. And what is this function? Well, libcuboid mv, we know that it comes from the libcuboid subdirectory, so it's probably going to need libcuboid data types. And we're going to do a move. And we're going to do a move from 000 to mml. mml is here. So what we're saying here is x is m, so 5. Y is m, so also 5. And L, the Z column, is the last point, which is 10. So that particular function will give us a translate of 5, 5, 10. Pretty simple stuff. Okay, we'll just add them all back in again. My next statement, my next translate statement here, gives me another point. Zooming round. So this is our quadrant 1, this is our quadrant 2. And what we're saying is I want to know the translate from L00 to MML. Now MML is exactly the same as the MML as before, but our starting point is different. I'm taking the anchor point of this cube and moving to MML, which is the top here. Probably not explaining this quite correctly. Let's rem that out. Let's rem out everything bar. So this cuboid is being rendered with L00, so that's in quadrant 2, and we're going to go, and this statement, which is a translate and a cylinder, which is an OS standard piece of code, is saying I'm going to go from LOO, this point, to MML, this point. So even though MML is the same as the MML of before, because the starting point is different, we now get to a completely different place on the cuboid. And that can be really confusing because we're actually starting from the same point, but from the point of view of the graph, it's different. Anyway, I hope I've described that, and this is a summary, so there you go. So what we have here is a bunch of translates which are being calculated for us, and we're printing a cylinder. The whole point about this piece of code that I'm showing you here is that one function at the top, an OS standard command, is changing all of this to the color green. That's all I'm saying. The next piece, got another block which is identical to the previous block, but in this case, I've got a sphere on the end. And I've also got a translate. So what this is doing is it's taking this block of code and it's translating it with an absolute translate, which is a bit naughty, by 5 units in the Z secretary, and it's going to make them red. The whole reason I'm doing this is to show you that a single translate can affect an entire block. And if I wanted to, if I was doing this properly, what I would do is I'd actually define the cylinders in OS++ in a proper variable, and then simply do another translate. But again, we'll discuss that later. The other thing about this particular example is, for a giggle, I've changed the roundness. So you can see that this is a little bit rounded, a bit more rounded, a little bit more rounded, and then finally super rounded. And that is that, I think. I think we've discussed everything. Yep. I'm going to pause it there. Right, let's do some examples. We're going to go into a subdirectory I created earlier called My Examples and go into Learn the Hard Way. Here is Learn Hard file, and I've put a little tab in so that I know where to start. So this is example 2, and we're moving on to example 3. Right, so what do we have here in example 3? Well, if I rem my rems out, my block rems, I have a cylinder. How exciting is that? So basically the instructions say this is an OS standard cylinder, and it explains that it does not grow, unlike a cuboid, from the 0, 0, 0, 0, 0 corner, but from the middle 0 corner, i.e. here. As a result, the OS standard shape has an anchor point of middle, X is middle, Y is middle, Z equals 0. So what happens when I want to place a cuboid on the top of that cylinder? OS++ allows me to render that cuboid in exactly the same way as the cylinder. So what I've got here is a translate. I'm moving up by 30 in the Z axis, which just happens to be the height of the cylinder, and then I'm printing or rendering a cuboid in exactly the same way as this cylinder is rendered, but on top. And as a result, I could add more and more shapes as I wanted. Now the reason I show you this is that if I was to lathe this, this would be spun round and I would cut this particular cylinder out of that block. So there you go. We're rendering a cuboid as we would a cylinder. Next example. Now obviously we've got three primaries: a cuboid, a cylinder and a sphere. Here's my sphere. Straightforward sphere, diameter 10. I think it's diameter 10. No, radius 10. Right. Okay, in exactly the same way, you can see that the anchor point, or where it grows from, is right in the middle of the shape. So as we increase the size of the shape, see it grows from the middle. So if I wanted to work or think in spheres, but using a cuboid, I would use the anchor point MMM. Because if you increase the size, it grows in exactly the same way as the sphere does. There you go. Next example. Okay. This example merely shows you a cylinder and how a cylinder will grow from its base. Because the anchor point is actually in the base itself, as you increase the height of the cylinder, it has to grow up. As you can see, the cuboid with the same anchor point as the cylinder also grows up. And as we increase the z-axis by 1 each time, you can see it growing. Like a cylinder. Excellent. Next example, please. Right, this example shows you something that OS standard can't do. That is a cuboid growing down, as if we were drilling. So if we start with libcuboid, which is our cuboid, and we start with an anchor MML, middle of X, middle of Y, but at the top, that's the fixed point. As we increase the Z-axis, the only place it can do is grow down, as if we were drilling a cuboid downwards. So there you go. There you go. Right. Next example. Growing up and down. So yes, this is basically showing you, or wanting to show you, that if you create a cuboid using MMM, which is the center of the cube, as you increase the axis, the z-axis, it will grow up and down at the same rate as if it was a cuboid, a sphere. Very exciting. Let's move on. Next example. Right, obviously I had a lot of fun here. In this example, it simply shows you that we can grow sideways. This is where the fixed point is on the side, and as we increase the X value, it grows to the side. Obviously, we can try the other side as well. Our fixed point is the last part of X with Y middle, Z middle. And as we increase the X unit, it will grow in the X direction. So the anchor point will dictate how the shape grows as you tweak it along. And again, MMM, which again is the sphere. You see that it grows out in both directions. Next example. Finally, something a little bit more exciting. This example is purely showing you rounded corners, which I've shown you before. We have libcuboid, which says we're going to do a cuboid from the libcuboid library. We're going to create it using 0, 0, 0. So x equals 0, y equals 0, z equals 0. Our cuboid is going to be a maximum size of 10, 20, 30, but we're going to round the corners with a sphere of diameter 3. And as we increase 3 to 5, we simply make it more rounded. If I increase the FN, this will become much nicer. We can do that. Don't know if it's going to complain. There you go. You get a much nicer. There you go. Much nicer as you increase the FN. I'm using FN 20. Of course, if you specify 0, i.e. the spheres have no diameter, then you get a pointy cube, which is identical to this. So effectively, this is a superset of this. I wouldn't recommend doing it because it has to calculate 0 size spheres and columns, but it would work. It would render. Logically, it's correct. Just you wouldn't do it because it would require a lot of time. Right. Next example. Okay. This is going to talk about rounded. So we've got a pointy cuboid and we have a rounded cuboid, which has got rounded corners. Very often we want shapes which don't have rounded corners, but some are rounded. And what we do is we have to allocate or remove a face. So this is basically saying, hey guys, give us a cuboid, render it using the 0, 0, 0 anchor point. My sphere is going to be 10, 20, 30. X is 10, Y is 20, Z is 30. I want the corners to have a diameter of 5 on them, but I don't want Z0 to be rounded, so it's flat. Z is the Z-axis, and 0 means Z equals 0. So Z0 is the bottom, ZL is the top. So with this command, the bottom of the shape is rounded, but the top is now flat. We've just chopped it off, as it were. It's still the same size, still 10, 20, 30, but the top face is flat. And we could do the same for x equals 0 and the last point of x, and y equals 0 and the last point of x. So basically what I've done is I've named the faces. Z0 is where Z equals 0, the bottom face. ZL, where Z is the maximum it will be, or the last part, is the top. X equals 0 is this face. X equals L is this face. Y equals 0 is this face. Y equals L is all the way around here, this face. So we have 6 faces. Each face has a name to do with its axis. And these are showing you these examples. And all we're doing is we're saying minus. We're gonna start with a full R cube, and we're gonna remove roundness from these particular faces. Okay. If we go down to the bottom here, give you a demonstration of how why you do that. We have 2 shapes. One is a cuboid where we've specified that x0, where x equals 0, is going to be flat. And the other shape has the opposite, that xl is flat. And by actually changing the anchor point, we've done this wraparound business where we can actually specify where this shape will sit in global space, as it were, or the graph space. And because they're side by side without even any translates, we can just add them together and union them together, and they will tessellate or fit together nicely because they're both flat. Next example, please. Of course, very often we don't want just one side to be flat, we want 2 sides to be flat. So all you do is you specify both face names after your minus sign. So in this case, x0, this edge is flat, and y0, that is flat. Now, there is a precedence. x0 always comes before xl, which always comes before y0, which always comes before yl, which always comes before z0, which always comes before zl. These are the 6 faces. So z0xo, well, that's not the right order, so that's bad. Xo always has to come before z0. So that is the face order when specifying the face here. So basically, as I said, we want a cube. We're going to give it an anchor point of 0, 0 here. That is the size of the cube. We want it to be rounded, but not where x is 0 and y is 0. What does this give us? And what it allows us to do is it allows us to create a shape like this. Okay. Let's do this. Build it up nicely. So first shape, anchor is 0, 0, 0, or the translate point is 0, 0, 0. We're going to anchor this particular shape to X is the last point, Y is the middle, hence it's in the middle, and 0 means that Z is at the bottom. And we're basically going to remove the whole, we don't want XL, this face, to be rounded. This is our second shape, and as you can see, X0, Y0 are both flat. And our third shape, you can see X0 is flat, which is this particular face, and YL is flat. Here's YL, the last face. All using the same translate point here. And if we unrend them all, we get the full shape, which of course we could union together to get. Right. This example, its sole purpose is to explain this command. Now, obviously writing Z0, ZL gets a little bit frustrating. So minus Z is equivalent to Z0, ZL. Or alternatively, a way of thinking it is I want both the top and the bottom to be flat. Both of these commands are identical. Just that's a lot easier to type. To prove it, nothing happens. And of course you've got X and Y. Okay, let's rim you out. So why do we care? Right, create a little module called tongue and groove. This is the code. 5. Right, we've defined 2 cuboids, just variables. The top variable has a roundness of 5, but not in the Z direction. The second one, the same, but a smaller one. Here is our method. Now to break it down, we've got, this is an object. What I've done is I've added the 2 shapes together. So shape 1, and then translated to the top of that shape, and then rendered shape 2. Because it's been unioned, this is considered one shape now. And then I have removed this shape. So effectively, I now have a bottom. So if I 3D printed this, I don't think it would 3D print, well it might do. What it means is this shape will tessellate, it will actually, the tongue will fit in the bottom groove. I can actually simplify it a little bit as well, easier to take away. So as I said, we generate the shape, move to the top of it. So if you look, we've got a translate, which is a move. We're moving from MMO here to MML here, and then we create, or we render the second test shape here, which is the little one here. So when I do the difference, because it's the translate is back to 0, 0, 0, it will then render the test shape test2 out of the bottom. Yeah. There you go. Right. Okay, next example, what have we got here? Ah, right, okay. Right. In this example, we are adding rounded corners. So in the way this works is, F5, you'll see, we start with a pointy cuboid and then add the roundness. So rather than with a minus, we start with a full R cube and then we remove faces. With this format, we start with a pointy cuboid and then add roundness. So XO is the only face which is going to have a roundness of 5. So here's your XO area. XL, which is opposite to XO, is rounded, and so on and so forth. The shortcut is also available. So if I hit F5, didn't want that one. Let's go with that one. Makes life easier. So plus Z would mean that the top face and the bottom face is the only faces which are rounded. Everything else, as you can see, is flat. And that is identical to Z0, ZL. Oops. If I hit F5, exactly the same. Just to prove it, there you go. So I've said that only Z0, the bottom face, is going to have a rounded section. Top face, oops, both faces, which is equivalent to just Z. This is a demonstration of plus, but with two side, so XO and YO. So effectively, XO is this face is rounded, YO this face is rounded, and then everything else is pointy. And here's an example of 3. Where XO, YO, and ZO are all rounded because we're taking a pointy cuboid and then adding roundness to those particular faces. And here I'm showing you that you can actually mix and match these things. So this is the equivalent of XO, XL, exactly the same. And it's just shorthand. Now, X always comes before Z, and therefore it's XZO. And as you say here, we could have used XO, XL, ZO, but it's easier just to write this in shorthand. And that is the end of part 2. Well, for the examples anyway. Quiz time. Question number 1. Lib cuboid MMO 101030 will render with the same fixed anchor point as option A. A cube from OS standard. Option B, a default cylinder from OS standard. Option C, lib cuboid with the same anchor point as the question. Option D, lib cone R grid with the same anchor point as the question. Option E, lib sphere with the same anchor point as the question. Option F, all are correct except A. Your answers, please. Question 2. Translate 005 semicolon sphere 5 renders exactly the same way as sphere 5. Why does the translate have no effect? A, the sphere will render 5 up in the z-axis. In other words, it will have an effect. Option B, you put a semicolon after the translate. It should be translate 005, no semicolon, sphere 5. Option C, this has nothing to do with the OS++ library and is an OS standard thing. Option D, A and C are true. Option E, B and C are true. Your question, please. Your question, please. Your answer, please. Question 3. You copy and paste lib cuboid, quotes 000, quotes rather complicated thing, and it does not render correctly. A, yes it does. The syntax is fine. B, no, because the quotes are a 66 and need to be translated to quotes as in a straight quote, as the font conversion is wrong. Option C, no, because the roundness option is -XL XO, and it should be -XO XL. Either preference is XO XL YO YL ZO ZZ. Sorry, ZL. And it doesn't meet that preference. D, both B and C are true. Option E, check the quotes, but this syntax is fine with the latest OS++ version. Try lib cuboid, straight quotes, anchor point 000, open double brackets 10 10 30, close single brackets, comma 3, comma, and then quotes -XL, comma XO, comma, and then it closes all the command off. Your answer, please. If you want to translate or navigate through a primary from the base of the cuboid to the top, how would you do it? It gives the question has a render, a cuboid render, which is lib cuboid 000, comma 10, 20, 30. Option A, we navigate from MMO to MML, and then it gives you a command. Option B is we navigate from 000 to 00L, and it gives you the command. C, we navigate from MML to MMO, and a command. And D, we navigate from 00L to 000. Option E, A and B are correct. Option F, C and D are correct. Now there's a couple of things I want to outline. The cuboid render at the top starts at 000, and option B also starts at 000. Option A and B are the same as C and D, but the to and the from have been swapped round. So whereas A is MMO to MML, C is MML to MMO, the other way around. Your answer, please. Whew, these are getting nasty. Question 5 is plus XO, YO, ZO, I adding rounded faces to a pointy cuboid the same as -XL, YL, ZL. i.e. removing rounded faces from a rounded cuboid. So basically what I'm saying here is that XO and XL are opposite faces. YO and YL are opposite faces. ZO and ZL are opposite faces. So is adding roundness to a point from a pointed cube the same as removing roundness from a rounded cube? Option A, yes, that's logically the same. Option B, no. Option C, this has not been discussed yet. Option D, B and C are correct. Option E, A and C are correct. Your answers, please. Question 6. When naming a non-rounded side, you forget the minus and enter X. Is this the same as minus XOXL? I. You type the command in lib cuboid, anchor, standard cuboid, comma, X. Option A. There is no sign, so X is invalid. Fair enough. Option B. Yes, yes. If there isn't a sign, the default is minus, i.e. we can have a minus. C, no, but I'm not going to tell you why. D, no. If there isn't a sign, the default is plus. Your answers, please. And finally, question 7, I hope it's finally. If I navigate from 000 to LLL on the cuboid 10, 20, 30 with a roundness of 2, will the resulting translate be the same as the navigation from 000 to LLL on a standard cube of 10, 20, 30 with a roundness of 7, i.e. the rounded cuboid is now more rounded? And then it gives you a set of commands, and both commands are the same except the very last section to say that the roundedness is the same. And we've got two options. Option A, yes, these are the same. The rounded corners are irrelevant to the grid. B, no, the corners are more rounded, so the length from corner 1 to 000 to corner 8 LLL is different. Your answers, please. I think that's it. Yep, that's it. Right, I'm going to answer these. Now, if you want to play along, you can go into OS++, the website. If you go to OS++ 2022 videos index, if you basically click this icon here, you will have these support files. So you've got the quiz and you've got the support files, which I'm just about to go through. If you want to download them and run them at the same time rather than having to type them in because you want to play with them, that's cool. This is where you'd go. This particular video is #0003. 0003. Just run down it and you should find it. Okay. So hopefully, if you download it, you should have all these files. Now, files to here, these are the files I've already used as examples. And then the following files, question 1, question 2, question 3, question 4, question 5, question 6, question 7, are files that are answer the questions. So let's go through those questions. It says. So the first question, question 1, libcuboid MMO 10, 10, 30 will render the same with the same fixed anchor point. And then we've got a whole bunch of options. All right. Going into question 1, openscad. Right, what have we got here? Right, the first thing is we've got option A, B, C, D, E, and I've basically created the same commands. However, I have put in these two variables. So height is the height of the object, and XY is simply, if it's a cone or a cylinder, that's the diameter. If it's the cuboid or cube, then it'll just be the X and the Y. So it'll be X10, Y10, and I'll just call it XY. If you look at the top here, I've got a parameters, and what that allows me to do is if I hit F5, I should have these parameters. So what I've got here is I've got this is the original command from question 1, and we've got an anchor point of mm0, xy, xy height. So xy, x is 10, xy, y is 10, height, the z-axis height is 35. So if I increase 35, you can see it grows. I'm just simply increasing the numbers or decreasing them and then hitting F5, and it just quickly calculates it. So let's move, can we move this bit? There you go. So in this case, if we look at the base, we can see that the base is mm0, which is x equals the middle, y equals the middle, and z is the base. Okay. Hit F5, and that's not good. What have I done wrong here? I did think I tested all of these, but clearly not. Ah, yes, of course. Sorry about that. So cube, xy height. Here is our cuboid. And as you can see, it's actually growing out of 0, 0, 0, because that's the default for OS Plus. So if I increase or reduce the height, you see it shrinks towards that. And as I reduce or increase, so this is the only fixed point and it moves towards that fixed point, whereas before, the fixed point was here. So no, option A, that's not good. It's not, they're not using the same anchor point. Okay. Right, this is a cylinder. This is the OS the OS standard cylinder. Height is 35 and the diameter is 10. So diameter is 10, height 10. And if we increase and decrease it, you can see that it shrinks to that point, which is the middle of X, the middle of Y, and Z equals 0. So cylinder, my fixed anchor point is identical to this particular OS++ shape. Okay, now the following, option C, D, and E, they're all OS++ shapes or primary shapes. And you've got lid cuboid here, which gives us a cuboid. You've got the cone, which gives you a cone. And you've got a sphere, gives you a sphere. And each one of them has got exactly the same anchor point as our example. So it's going to grow from the same anchor point as standard. It's just that it's a grid, it's a cone rather than a cuboid. So we've spent plenty of time on the cuboid. Let's have a quick look at the cone. All it is I'm saying I want a cone. I want it in the Z-axis, so it points straight up, which is the default. I want a height of 35, which is there, and a diameter of 10. Oh, I should have put XY in there. Gosh, coders. Ta-da. So as you can see, as I increase it, it acts exactly the same as a cylinder. Of course, if I change this to the y-axis, I get it on the y-axis, or I get the x-axis, the x-axis. But I found that understanding everything is a lot easier if you say it in the z-axis. But when you're modeling, you will probably use an X or a Y and navigate through that shape. So very often if I've got, a sphere on the end and a sphere on the end, I will navigate through the shape from MMO to MML or depending on how it goes. Yeah. The sphere, Same sort of thing. There's its anchor point. If I hit 5. As I increase the height, there's only one option. There is no X and Y. It still grows from that point as before. So, in summary, option A, no, it hasn't got the same anchor point. Option B, yes, it does have the same anchor point. And these three options, they all have the same anchor point, which is basically said in the command, and therefore they all have the same anchor point. So there you go. Let's quickly remove that. Okay. Question 1, the answer is F. All are correct except A. There you go. Question 2, translate 005, semicolon sphere 5 renders exactly the same as sphere 5. Why does the translate have no effect? Okay. Okay. Here's the code. So I've got model main. There you go. And I've got to translate 0,05 semicolon C5. So if I push F5, oops, perhaps. So translate 005, sphere 5. The claim is that is identical to just sphere 5. So I'm going to hit F5 so it disappears and then regenerate it. So yes, the claim is correct. Sphere 5 is the same as translate 0,0,5 semicolon sphere 5. What's going on? Well, basically what's happening and he's left the semicolon in. Basically what's happening is that the semicolon resets the translate point. So this command and this command are the same because the semicolon basically only works on the command that it's got access to. So this effectively is a block. Am I explaining myself well? Basically, semicolon after translate, bad. So to try and demonstrate that, what I've done is I've got a second program, and I've got like the traffic lights of green, amber, and red. So here's our main module. What I've done is I have a translate statement, and all that does is it's pushed this block up by 5, and I've just moved it to the side so you can see the numbers. So you can actually see that the green ball is at 5, the yellow ball is at 10, and the red ball is at 15. That's the only reason I've done that. So what's going on? So the whole thing, this whole block has been shifted, no semicolon. The moment I put a semicolon in, that translate no longer works for that block of code. So no effect. Take the semicolon out, has an effect, all move up. Because that is a full block, the whole thing is moved up by 5 and 3. Okay. The first sphere, that's just printed, that's just rendered. So there's no translate statement, so that's going to be at 305. So if we looked really carefully, 1, 2, 3, and at 5. No, yeah, it doesn't have the number. There's 10, that's 5. 1, 2, 3, 5. All right. The yellow sphere has also got a translate statement. And it's gone 005. So we now have 3, 5 plus 005. Boop. We're now at 10 because it's a cumulative. Look, again, no semicolon. The moment I put a semicolon, bad things happen. The yellow is now at 3, 0, 5. Take the semicolon out, goes in its proper place. But the last thing I wanted to show you was the red sphere. And what I've got here is I've got 2 translate statements. Both of them don't have semicolons. So what's happened is we've got 005, 005, which gives us a translate of 0010. And of course, we've also got the 5 from here, which brings us to 15. So that is the wonderful world of translates. And that is a pure OS standard thing. That's nothing to do with OS++. In fact, if I wanted to, yeah, 5. I'm not even running OS++ now. The framework has been disengaged. This is pure openscad. This has absolutely nothing to do with OS++. But I wanted to show it to you because, you know, it can get a little bit confusing when you've got a really nasty OS++ function in there as well, and you're going from 000 to MML, and you're thinking, wow, why isn't this working? Well, the reason it's not working is because the semicolon. If you may have put a semicolon in. Okay, which is why if you look at my code, very often it'll have a translate with no semicolons here in the comment. But anyway, here you go. What have we got? Okay, translate 005, semicolon, sphere 5 will render exactly the same as sphere 5. Why does the translate have no effect? This is a true statement. So A, the sphere will render 5 up is incorrect. B, because you put a semicolon after the translate, it should be da, 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 da. That's correct. C, this has nothing to do with the OS++ library. It is an OS standard thing. That is so true. So B and C are correct. That one and that one. And that's the correct answer. Question 3, you copy and paste libcuboid. Oh, this is a nightmare. So, libcuboid quote 00 quote. If you look at the quotes, it's a 66 and a 99. These have been this text has been generated in LibreOffice, but I suspect most wordy text editors that aren't sort of Notepad are going to do exactly the same thing to make it look pretty. The problem is, unfortunately, openscad doesn't like it. So here's the statement copied straight in. You know, 5. And we get a really nasty red error, parse error, syntax error in Q3, blah, blah, blah. So basically what it's saying here is this doesn't work. You're looking at it going, it looks fine. Why? Why is it not working? And it is purely down to these quotes. These quotes are wrong. They're not a 66 and a 99. If you change the quotes to straight quotes, it works fine. So the only difference between these two is these quotes. So as I say, these are created when you literally hit shift, what is it, to get quotes? Oh my gosh, why do I get quotes? Where's the quotes? Oh, why have I lost the quotes? Oh yes, doesn't have a letter on my keyboard. The key is on the end near the enter key. If I hit the quotes here, they're nice and flat. If I hit the quotes in a word editor, it's a 99 and 66, which just doesn't work with openscad. So I can't fix that unless I go through and start changing OS standard, the actual IDE. So that's a little bit beyond me. The other thing that I've got here, libcuboid, if I hit F5, that's not what I wanted. Hit F5, hit F5 again. Right, it doesn't render, and I get an error message. All right. Basically, it's saying it's not been detected in the family XLXO. So what's happened is that the way that it works out which cuboid you're doing is it checks the precedence. And XO will always come before XL, and that's round the wrong way. So if I actually change it to XOXL, that will work perfectly. But with the wrong precedence, it won't work. You'll get this horrible error message. You think, what's going on here? Had a little think about it, and I thought, well, I should really change that. So what I have done is I have edited the code. So this is the old code, and you can see that it's running from 2022 10/31, which obviously means the year 2022, October the 31st, which is the last day in October. The new code is the year 22022, November 30th, which is the last day of November. Right, so let's have a quick look at that. If I hit F5 here, copy this out. Just copy and pasting so you can see the text. So when I have this include statement to run the OS++ framework, it turns around to me and says, I'm running the hello statement says, hello, I'm running this particular calling program, and it calls libcuboid 003, libcone 002, and libsphere 101. If I do exactly the same thing, but with my latest and greatest, so quick. Same copy and space, copy and space, copy and paste. Let's make it a little bit bigger for us. Right. So when I run this command, this calling command, and all I need to do is go into zlib and I can see all of these different calling commands. If I run this particular standard, it turns around to me and says, hey, you're running 2022 11/30, which matches that, which is good. But you'll notice that it's running a different set of versions. Now these versions are later, so 110 is later than 103. Now what does that mean? 1 is the major set of changes. This one is minor set of changes, and the last one is a bug fix. So what I'm basically saying is I've added some more features, and they're kind of minor. They're not, they're not earth-shattering. They just make your life easier. Well, they make everyone's life easier, hopefully. So basically, I've got exactly the same code, but it's been edited slightly so that I'm actually running a slightly different version. But that version is still there. This is canon. What I mean by that is if you have this command in your code and you download the latest and greatest, this command will still be the same, which will still load the old code. The old code is the standard. That's it. I can say anything I like in the documentation, but at the end of the day, if it works or doesn't work in this particular OS framework, then that's it. That is the standard. So what I'm trying to do there is add backwards. I've got backwards compatibility, not via the fact that it's exactly the same sort of code or it takes the same sort of input, but because you are actually running the same code. If it works with the old version, it should work with the new version because you're actually running the old version, if that makes sense. Anyway, what am I going on about? So we've got these two commands, and they are syntactically correct, but we've got this horrible idea of precedence, which I've been working with for quite some time. And the reason we need precedence is because if I've got 5 different faces that I'm putting in here, I would have to do some sort of search, and it's just a nightmare. Anyway, what I've done, new code. Hit F5. Gosh, let's see if we can close that out. So even though these are around the wrong way, what's actually happening is that the code will actually do a sort on this. So XO will actually get moved to XL, and XL will get moved to ZO, and it should find it. So effectively now, although it still uses the precedence, it does this sort so that everything gets sorted out the same way. So if you do put it in the wrong way and you don't follow precedence, you bad person, the code should sort it out for you now, but only if you run the latest and greatest, or this particular iteration of it. But if you want to, you can still run the old code, or if you've got code that runs the old code, it will still use this, and it will, even though it's been replaced, the code is still there. So while I was here, I thought I'd make a couple more changes. So this particular cuboid, XL, XO, you know, I see this and it makes perfect sense to me. But obviously, if you're tired, then maybe maybe commas would be good. So what I've done is I've put in the code a piece of code that actually removes commas. And what this means is if you want, you can space out your faces in the wrong order, and you actually see the faces themselves. So yeah, XL is this face and XO is this face. Normally XO has precedence, so it should be XO, XL. But because I've got a sort going through, it sorts it out for you. Right. And that also works with the shortcut when we say -Z. So for example, that's the top, -Z is the top and the bottom, XO is the side, and we're removing roundness so they're flat. Okay. Now the interesting thing is because the code just comes in and rips out the commas, the code will still run with as many commas as you like. You can add them as long. Why have I done that? Well, A, it was easy to code, and B, it's around the wrong way. If you're building up a string in some code or for whatever, and you happen to say, right, that is my face, I'm always going to put a colon on, this will be absolutely fine because it just comes along and rips out the commas. Just doesn't care. So, in summary, Z, XO, wrong precedence, but anyway, it'll expand ZO to ZL, XO. It's the wrong precedence. It'll do a quick sort on it. The sort will give us XO, ZO, ZL, which is the correct precedence, and then it will remove all the commas. Ta-da! So hopefully, moving forward, that is easier to read than that. But if you wanted to, this would be fine. I've also done some other stuff which I really shouldn't talk about. So I'm going to use a lowercase x. Still works. Gosh, I feel like I'm back at college. And if you're really naughty and you put a O in, XO rather than X0, it still works. Basically, it detects the O. Anyway, that should be XO. Ta-da! But if you by mistake put in X0, it will still work because it translates that to a 0. Quite easy to do, and then removes all the commas. Anyway, I think I've done that to death. Okay. Right. So you copy and paste lib cuboid, and it doesn't work. Yeah, that's because A, the quotes are around the wrong way. It should be straight quotes. And if you're running the old code, the preference is wrong. But if you're running the new code, which I suspect you probably will do because it'll be in the what's it called now? Oh, good grief. The templates. The templates will always have the latest and greatest in there by default because obviously I want you, if you're putting new code in, I want you to run the latest and greatest. It's only when you run your old code that I want to make sure that I actually load up the old code because they're canon. Anyway, so the answer is, if you're running the old code, make sure the quotes are correct, make sure your precedence is set. If you're running the new code, just make sure your quotes are correct because the precedence is sorted out by the new code. So the answer is E. Check the quotes, but the syntax is fine with the latest OSS++ version. Ta-da! Question 4. Okay. Oh God. If I want to translate or navigate through a primary from the base of a cuboid to the top, which one would I use effectively? And it's given me a whole bunch. So basically, when you create a object for 3D printing, what you're basically doing is you're taking a lot of primaries, spheres, cones, cylinders, rounded cuboids. You add them all together, merge them, so union them all together, and then basically what you want to do is you want to navigate through these shapes so that you can actually translate them to where they need to be relative to each other. Okay, so that's what we're going to do. So you might have like 20 odd objects and navigate through all of them to get to a single point. And what that means is as you change those primaries, that point will change with you automatically. So that's the benefit of it. But the thing is when you're thinking, I want to go from the bottom to the top of a shape, how do I do it? And it's given you a render statement. So this is the cuboid that's being rendered, and it's given you an anchor point of 0, 0, 0. Okay, let's have a look at the code I wrote. Oops. Let's open it up with openscad, not a text editor. Right, here are my options, option A, B, C. What I've done is I've popped an echo in front of them so you can see what the output of this particular function is. And then I've put in all the functions. And if I ran it, hit F5, yes, it works. Da, 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 da. Here's my render statement in the thing. If I copy and pasted this, I would get this, and there you go. And this is A, B, C, D. Right. What have we got here? So option A and B are identical to C and D, except the anchor points around the opposite way. So 0, 0 to 0, 0L is now 0, 0L to 0, 0, 0, and so on and so forth. And what happens is because they're around the different ways, pluses become minuses and minuses become pluses. It's as simple as that. So let's have a look at option A. It's saying we want to go from MMO here to MML here, and that's our output. And as you can see, the translate is 0 in the X, 0 in the Y, and 30. But hang on, my anchor point is 0, 0, 0. Well, that makes no difference. This is a complete red herring in there. I just put it in there to confuse everyone. So if I want to go from the bottom to the top, the only thing that can, if these are the same, as far as the X and the Y are concerned, they're going to be 0. So, put another option in. I don't know. Anything you like. Let's go. Because that is the same as that. Hit F5. There you go. I get a 0030, I won't bother to copy it in because it's identical. Why? Because if this is the cuboid, that's 000, that's LLL. So a jump from LL0 to LLL is just from the top to the bottom. So all of these are going to be the same because that, the XY and the XY on the 2, from the from to the to is the same. So effectively, option A and option B are correct. However, if I am coding and I want to go from the top and to the bottom, and I am using this particular shape, I will always use option B because it just makes more sense. You know, I want to go to the top. I rendered it as 000. That means I'm going to go to 00L. But in reality, there's lots and lots of identical commands that will give you exactly the same translate. If I do it around the other way, well, the translate's going to be the other way, so I'm going to get negatives. So the answer is B and A, and that is a complete red herring. So let's go back to the question. If I want to translate or navigate through a primary from the base of the cuboid to the top, the command I would use is this. If I'd rendered this, I'd say, well, I want to go from 000, the bottom, to 00L, the top. That would be my command. So I would say B, but I have to admit that MMO to MML is exactly the same thing. I'm going from the bottom to the top. So A and B are correct. Gosh, that's it. Question 5. Oh, this is a nightmare. Right. Question 5 is plus XO in the new format, YO, ZO. I adding a rounded face to a pointy cuboid. I'm adding the same as removing rounded faces from the rounded cuboid. So XO is at the bottom, XL is at the top. YO is at the bottom, YL is the opposite of YO. ZO is the proper bottom, ZL is the top. So what I'm trying to say here is it logically the same to add roundness to a pointy cube than it is to remove the opposite faces from a rounded face? That is the question. Option A, yes, that's logically the same. Now, if you said that, I'm all with you. I actually wrote the code and I was halfway through writing the code and I suddenly realized that actually that is not the case. And it took me quite a long time to work it out. So, no, they're not the same, and I will show you why. What have I got here? Expand it out. I've got removing my roundness from a pointy and adding roundness. Adding roundness from a pointy cuboid, removing roundness from I think I've done that around the wrong way, but anyway, it doesn't matter, same diff. Hit F5. So here's my two shapes. If we just focus on the Z, ZL and ZO, because it makes nice, it's the top and the bottom, you can see that they're different. When I say add roundness, not only is Z affected, but these four faces around it are also affected. The roundness affects all those four shapes, all those four faces. Whereas if I just straightforward cut it away, the other four are not affected in any way, shape or form, apart from the fact they're slightly more extended. So taking away or removing roundness is not the same as adding roundness. And as a result, the two shapes are completely different. And that really did throw me. I was halfway through the code, writing this code, and I was literally going to write, I'd written this code quite some time ago, actually removing roundness. And I thought because it would be logically the same, I could just simply get away with doing some sort of magic on this and just reusing the code. Only to my horror to find that they were actually completely different shapes. even though it sounded that they would logically be the same. It drove me insane. Not a great moment in sport. I was quite upset. But as you can see, if you're going to think in removing roundness from a rounded sphere, it is different from adding roundness to a pointy sphere. You get different, slightly different renderings. And that's all correct. I spent quite a long time going through and unit testing them and going, is that correct? Yes, it is. So there you go. Nasty, nasty question. But I am using the latest format, which is nice. Quite like that. It makes so much more, makes it so much easier to see that it's X, O, Y, Z. Anyway, so let's go back. Yes, that's logically the same. No, they're not. No, that's the correct answer. This has not been discussed yet. Well, it has now, but at the time it hasn't. So B and C are correct. B and C. So the right answer is D, I reckon. Okay. Nasty, nasty question. Many hours were spent on that. Okay, question 6. When naming a non-rounded side, you forget the minus and enter X. Is this the same as minus XO XL? Right, so what I'm saying here is rather than entering a minus, so we've actually turned around to the code and said, I want to remove roundedness from a rounded cube. I've just put in X. And my options are, and it gives you a nice little outlay, and the options are X is invalid. Yes, if there isn't a default, if there isn't a sign, the default is minus. No, but I'm not going to tell you why. And D, no, if there isn't a sign, the default is plus. All right. So when I wrote this code, I originally called this particular string NR. And what I meant by that was non-rounded. And I didn't have a negative sign. I simply just listed the faces that I wanted to have. Then later I added this ability, because I just got bored typing XOXL, where X got converted to XOXL. And then I came up with this idea of either adding roundedness or removing roundedness, which gives you two different shapes. So because I wanted the old code to work and I wanted it to be backwardly compatible, I made the default minus. Oops. The default is minus. So as far as the code's concerned, it'll see an X and slap in a negative sign and then process it as normal. So it'll sort of go, oh, okay. So it always is the negative side. And to prove it, yeah, 5. Ta-da! There's my cuboid. All right, so cuboid number 1, which is from here, minus XO, XL. No, I'm using the old code. Is the same as X, but without any negative. So if I put a minus in there, absolutely the same. Absolutely no difference. I can prove that the code is running. Yeah, 5, there you go. So basically the code comes along, pops in a minus sign for you, job done. Nice, easy question. And it's all down to the fact that when I first developed this code, this string is called non-rounded. And of course, there you go. It's only later that I added the idea of adding roundness to a pointy cube. Right. Are we there yet? Question 7. Dun, dun, dun. Right. If I navigate from 0, 0, 0 to LLL, so that's the bottom left frontmost corner to the top right backmost corner. On the cuboid 10, 20, 30, 2, will the resulting translate be the same as 0, 0, 0 to LLL on exactly the same cuboid, but with more roundiness? And then it goes on to say, i.e., are these two commands the same? And they're identical apart from the fact that the roundiness has been increased. And your options are, yes, these are the same. The rounded corners are irrelevant to the grid. All right. B, no, the corners are more rounded, so the length from corner 1, 0, 0, 0 to corner 8, LLL is difference. Right, let's run up the code and let's have a look. So, what do I have here? I have my cuboid. I'm saying I'm going to go from 0, 0, 0, and each of them are the same, to LLL. So I'm saying I want to go from this corner to this corner, and I've got a pointy cuboid with no roundness, or a roundness of 0. If I increase it to 2, let's go 7 because it makes it more obvious here. 5. I've now got a much more rounded. Let's 5. So I've got a much more rounded shape, and the question is am I going from the corner to the corner, or am I going from this corner 0, 0, 0 to this corner here? And the answer is yes. It makes no difference as far as the code is concerned how much roundedness you add. This particular echo, which pops out in the console, is identical to this one, which is identical to this one. So what gives? What's going on here? Surely, if I'm going from corner to corner, I should have a shorter distance. And the answer is no. What's happened here is, as far as cuboid is concerned, you are in the grid, and you're in the X, Y, Z grid. And the fact that you've said it's 10, 20, 30, a move from 0, 0, 0 to LLL is going to give you the translate of 10, 20, 30. And it doesn't matter how much rounded you have. And you might say, well, hang on, Stephen. I want the pointiness. If I'm translating from point A, from this corner to that corner, I want to know where this point is. And of course, I've written code that does that. But you need a new letter, and the new letter is P. So what does P do? I can't really get this. There you go. P is the point on the x-axis where the x-axis touches, the cuboid touches the x-axis. Lowercase p is that point, uppercase P is this point. And from that information, you can work out where the corner is. You're just going to have to believe me here. But what I'm basically saying is that, let's do it for a giggle. Let's go with that one. Let's see. This is going to look really weird, but there you go. I will be describing this later on, and it will hopefully make sense. So what have I got here? 3 P's. This is the center of this sphere. 3 uppercase P's. This is the center of this sphere at the top. So PPP, uppercase P is the same as LLL, and lowercase p is the same as 0, 0, 0. This will make sense later. But if I do this command, I get a very different result. Very different. And the reason is I'm actually going from this corner here to this corner here. Not the corner, the center of the sphere on the corner. And that gives you a different number. And that's useful if you want to add objects, which I do later. So, in summary, the cuboid is, when you're talking about the grid is X, Y, Z, and it doesn't change. So if I put a sphere into my grid, let's render this all out. Coding on the fly, never a good idea. So if I have a sphere, what did I go? Let's go 20. I think that works. No, what have I done wrong? Lib sphere. Oh, of course. Okay, so here's my sphere. What I've basically said is I want a sphere. I want a sphere, but I want it to be in the R grid. So when I say, sorry, R stands for render, and grid stands for it's in the grid. So effectively, that is in the same grid as this. Now, if I did a move from 0, 0, 0, if I did a lib sphere move, grid, from 0, 0, 0 to LLL, using this, I would still get from here to here, even though it's a sphere. Because we're talking in grids, LLL, sorry, 0, 0, 0 is always here, LLL. So basically I've put this sphere into a grid. And it's exactly the same with the cones as well. The cones are put into a grid as well. And to signify that I'm not talking in terms of thinking in spheres, I'm thinking in the grid, I've added the word grid. And that, I think, covers it. So, effectively, in summary, 0, 0, 0 to LLL, always this point to that point, to the end of it. Doesn't matter how much roundedness is in there, it's always going to be this point to that point. And obviously, if you're thinking in rounded cuboids, you're going to want to know the points. And I've got a brand new letter, which it does actually make things a little bit simpler. I know it doesn't look like it right now, but yes, there you go. Anyway, let's go to the next question. Oh, no, that's it. So, yes, these are the same. Yes. So basically, that's the answer. Yes, these are the same. When we put this into it, it's the grid that counts, not the shape. And I've added new letters to help with the roundedness of the cuboid. And that's it. So if that's it, what's that? What is this bug? Bonus material, here, 5. So I'm going to go into Windows. I'm going to bring up the customizer. Here's my customizer. I've hit F5, click on parameters, and I can change the roundness of this cuboid. So 0, pointy, yeah. A little bit roundness, bit more, bit more, bit more, bit more. What am I trying to show? Well, I'm trying to show you that the code works fine. Works fine, he says. As I increase it, I'm taking more and more roundness off the cube until I have so much roundness taken off, I have a sphere. So in effect, if you wanted to, you could actually use that command for spheres. I'm not recommending, I'm just saying. The problem comes is what happens if I add more roundness? Well, the code doesn't turn around and go, you know what, that's a really silly idea, I'm going to throw an error. It lets you do it. So if I go to 11, you can see that the spheres. So what's happening here is the spheres are now bigger than the shape itself, and so they've burst out. Now this is wrong, you know, this just makes no sense whatsoever. What should be happening is that the shape should be confined to 10, 10, 10. But the roundedness of the spheres has burst out the other side. So 23, these spheres have got a diameter of, let's make it prettier. These spheres are actually bigger than the shape itself, and as a result, they've burst out. And rather than going, no, you can't do that, I've just said, off you go. So what this means is this code will give you that shape. Now, eventually, I'm going to sort this out because it is wrong. The shape should be confined to this area. So what should be happening is I should be making, rather than having a sphere on the end of each corner, I should actually have, what are they called? Ovals. But in 3D, obviously, as you get it. But obviously, if you write code and you rely on this shape, I don't know why you do that, but let's say you did, and I come along and I change it, your code won't work. Well, it should do. Well, it will do because actually you're running the old code. But the moment you upgrade to the new code, if I fix this problem, your shape would be different. So this is why I'm so insistent of making old code available, and it's simply called by this particular statement. So if you meet this standard, if you write code to this standard, it will bring up the code, and the code is the standard. I can turn around and say, well, this means this and this means that, and okay, fair enough. But if the code generates this shape, then that's it. That's canon. Incidentally, what really began to scare me is, let's say you can also add, you can turn it into a cone as well. So as I increase around, so all I've done here, exactly the same object, minus Z. All right, so the top and the bottom are flat. So when I add the roundness, you get a cone. So I've actually made a cone. So if you wanted to, you don't actually need to use, I've spent hours on sphere and I've spent hours on cone, getting it all right. But in theory, you don't actually need, if you were prepared to put up with this syntax, you could generate cones, no problem. And the interesting thing, of course, is 000 to LLL is still the same. Doesn't matter what you've done into the shape. Oh dear. So if I wanted to move that to there, what would I have? It would be Z is M. Go backwards. Z is M. Y is M. And have I done it right? Yay! Gosh. Anyone think I know what I'm talking about? So here I have a cone, which I've created. All I've done is I've rounded off the edges in the X coordinate from a cuboid. Please don't do this because this is a nightmare. I'm just showing it to you. But the point is, if you did write the code and you did rely on this bug, gosh, would anyone want such a shape? It's there forever as long as you use this. So the moment I come in and fix this properly and actually make sure that this shape stays within its bounds, there you go. Anyway, I think I've laboured the point. So let's go back to our... So when I said that I would take you from here, and then I would take you to here, I think I've done that. This is, quite frankly, the same object, just with added roundness. So, there you go. I hope you've enjoyed that, my insanity. There you go. Let's stop it.